Okay, so let's start. As you guys know, today we will be inshallah resuming vectors. Okay, and not just resuming vectors, inshallah we'll finish the non-velocity part of vectors. Okay, so let me share my screen with you guys. Let's do a recap as well before we start. So in the last class we did a bunch of concepts. Okay, so first of all we learned what is a vector quantity, what is a scalar quantity. Okay, so a scalar quantity has only magnitude, whereas a vector quantity has magnitude as well as direction. Okay, a couple of examples are velocity, displacement, and acceleration. Okay, both of them could be plus. I mean, all three of them could be plus as well as minus. So that's what makes it a vector quantity. And plus and minus mean different things. Okay, like for example, speed, we know it has to be positive. Same with distance, same with time. Okay, so that's what makes it a scalar quantity. And stuff like volume, any form of length basically, or any product of length is also a scalar quantity. Okay, and then how do you represent a vector? Well, there are three ways in which you can represent a vector. One is that you can write the x and y component separately. Okay, the other is that you write it in ij form. Okay, so I is like representing the horizontal component, j is representing the vertical component. Okay, and the other is that you can use letters. Okay, so you have OA, which is equal to A, and this is something that you will find normally in shapes. Okay, where we don't define A, as in we don't break down A in terms of x and y components. Okay, that's already been done, but whatever that is, we call it as OA, which means that if you go from point O to A, that's going to be equal to vector A. Then how do you calculate the magnitude of a vector? Magnitude is basically length of a vector, and you do that by, it's like calculating distance. Square root of x square plus y square. So basically square root of the square of x component plus the square of the y component. Okay. Then we did a few examples where we were given a vector and we had to find the magnitude, or in some cases we were given the magnitude and we had to find out the possible values. Okay. Then what makes a vector equal? When you have same magnitude and direction. Okay, so since a vector quantity is such that it has a magnitude as well as direction, so for two vectors to be equal, the magnitude and the direction, both of them have to be the same. Okay, now what makes two vectors negative vectors is when they have the same magnitude but opposite direction. All right, and then you have parallel vectors, which we can further break down into same or in parallel and same direction, parallel and opposite direction. Okay, but and what makes two vectors parallel is when they have different magnitudes but the ratio of the components is the same. Okay, like for example AB and PQ, you can see here are parallel. Why? Because minus 3 upon minus 6 is the same as 1 upon 2, so they're parallel and in the same direction. And PQ and XY, if you look at it, they're parallel but in the opposite direction. Okay, because you can see that when you simplify the two ratios, you get a minus sign. Okay, and another thing to keep in mind is that you can always work out the gradient of a vector by simply taking the y component and dividing it by the x component. Okay, it's like y2 minus y1 over x2 minus x1. Okay, then we did a few examples, and then the last concept we did was, by the way, parallel and collinear. Okay, so let me ask you guys, let's see how much you guys remember. What's the difference? How do we distinguish between two vectors? How do we distinguish between parallel and collinear vectors? So let's put it that way. There's one easy way to distinguish between them. What is that? Yeah, that's true. Okay, so if you apply the ratio thing, you'll notice it's the same. Okay, so just by the ratio, you won't be able to distinguish whether two vectors are parallel or collinear. But if they're collinear, there has to be a common point. Okay, which means that tells us that from the point where one vector ends, the other starts. Okay, so like for example over here, AB is 3a minus 4b, BC is 9a minus 12b. If you work out the ratio, you'll notice that it's the same. But does that mean that they're parallel? No, that means that they're collinear. Why? Because you can see that both of them have a common point. Okay. All right, now let's talk about addition of vectors. Okay, so when we have to add two vectors, the head of the first vector should be equal to the tail of the second. Okay, that's why we call it the head to tail rule. Whenever we are adding vectors, we follow the head to tail rule. So AB plus BC are two vectors that can be added and the result will be AC. PQ plus QR are also two vectors that can be added and the result will be PR. Just like that, XY plus YZ can be added. Okay, and so on and so forth. Okay, and then we did a few examples. What we're going to do today is we're going to learn subtraction of vectors. Okay, so one important point to remember when you're subtracting vectors is that the starting point should be the same. Okay, so two vectors are only subtracted when the starting point is the same. Now, what does that mean? Let me show you. So if, for example, let's say we have OB minus OA, so both of them have the same starting point, okay? So these two vectors can be subtracted, and what will the result be equal to? The result will be equal to AB, okay? Now, there's a very simple trick which you can remember, which you can learn, and then apply it over and over again. So basically, this trick is that the letter that is near to the equals to sign comes first, okay? And the letter that is away, or you can say far away from the equals to sign, comes after, okay? And the rule is that the starting point should be the same. So this is one example. Let's do more examples. So let's say that you have OP minus OQ. Okay, so the first question you need to ask yourself is, can I subtract these two vectors? Okay, if the answer to that comes out to be yes, which it will. Why? Because the starting point is the same. Okay, and then the next question you need to ask yourself is, what is the result going to be if these two vectors are subtracted? So the result is going to be, so what's closer to the equals to sign? Q. And what's away from the equals to sign? P. So the result is going to be QP. Okay, let's do another example. Let's say you have AC minus AB. Can you subtract these two vectors? Yes or no? Yes, you can. Okay. Now, if you do subtract, why can we subtract these two vectors? That's because they both have the same starting point. Okay. Now that we've decided we can subtract them, what is the result going to be? Yep. Vector BC. Okay. What about LM minus LN? Can you subtract these two? Yeah. Yes, you can. And what is the result going to be? NM. That's correct. Okay. Now, when do we use this, or how do we know that we have to add or subtract? For that, you guys will have to hold on. Okay. When we do questions, you will understand when we decide what it is that we need to do. Okay. Acha. So, a couple of more concepts that we're going to do. One is something called a position vector. You guys know what a position vector is? Yes. A position vector is basically a vector relative to the origin. Okay. Now, what does that mean? What does vector relative to the origin basically mean? Okay. So let's say that you have a point. Okay. Say you have a point A. Okay. With coordinates, let's say 2, 3. All right. Now, A is a point on the xy plane. And if it has coordinates 2, 3, that means it's going to be somewhere over here. All right. Just a rough estimate. Okay. Obviously not drawn to scale. But the thing is, these points have a starting point. Okay. The x coordinates have a starting point. The y coordinates have a starting point. And that starting point is the origin. Okay. We don't just randomly place a point. Okay. We have a point from where we start counting. Okay. And that point, as we know, we know it as the origin. Okay. So right now, this is written in what? This is written in point form. Okay. Point form where you're given the coordinates. But what if I wanted to write this in vector form? So in that case, I will write it as OA, which is telling us that we are coming from O and we're stopping at A. And what is the vector OA? It's 2, 3. Okay. Or you can write it as 2i plus 3j if you want to write it in ij form. Okay. So this is how you write a vector as a position vector. Okay. Now let's do another example. Let's say you have a point P. Okay. This is example 1. Let's say you have a point P which has coordinates 6, minus 1. Okay. Now how will I write this as a position vector? OB equals to 6 and minus 1, or I can write it as 6i minus j. Okay, depending on. So by looking at the question, you'll understand how we decide the way we want to write it. Okay. So we've done two concepts, subtraction and position vector. If you guys have any questions, feel free to ask. So now we're going to do some some example questions related to position vector. Okay. So we're not going to do all of them, of course. We'll just do a few of them, and then I'll give you guys a few questions to solve. So it says find AB in the form of AI plus BJ for each of the following. So notice that we have A and we have B. So the first thing you want to do is you want to write them in vector form. Okay. So if you have the coordinates of A 4 comma 7, that means what you technically have is this 4 and 7. Okay. And then just like that, if you have the coordinates of B 3 comma 4, that means what you technically have is this OB, which is equal to 3 4. Okay. Now here's a question for you guys. We've done addition, we've done subtraction. How can I rearrange these two vectors so that perhaps by adding them or subtracting them, I can get AB? Yes, perfect. So there are two ways. Okay. One is that if you want to do it by subtraction, which is what I would recommend, I would strongly recommend that you use subtraction because there's less work. You don't have to change anything. So if you do subtraction, you'll have to do OB minus OA, and that's it. That will give you vector AB. Okay, we just saw the rules of subtraction. Okay, तो ये उस पे पूरा बैठ रहा है. The other rule is the addition rule. Okay, now if you want to do it by addition, that means you then have to do AO plus OP. Okay, and you will have to sit down and think about it, what it is that you need to add or subtract in order to get what you want. Okay, don't think that there's a trick or there's like a formula which will tell you what you need to do. Okay, just do a bit of trial and error. You'll understand what it is that you need to do in order to find out what you want. Okay, so this will also give you AB. Why? Because here the rules of addition are being followed. Okay, now like I said, what I would recommend strongly is subtraction because you don't have to change anything. क्यों? क्योंकि अगर आप एडिशन करते हो तो फिर आपको you'll have to change OA to AO. Okay, and how will you do that? How will you change OA and convert it to AO? Question for you guys. Yep, you'll have to multiply it by minus. Okay, so that's just inviting trouble. Who knows that we might end up making a sign error or something. Okay, so don't do that. So let's go with subtraction. OB minus OA. Okay, so OB minus OA means 3 4. Okay, minus OA, which means 4 7. So 3 minus 4 is equal to minus 1. And please do not end up writing this as a fraction. Okay, I've seen this happen. Students end up writing it as a fraction. This is not a fraction. Okay, so minus 1 minus 3 is your final answer. Now, just in this example, I'll show you how to do it through addition as well. Okay, but like I said, you don't have to do it through addition. So if you wanted to do addition, you would do AO plus OB. Okay, so AO would be minus 4 minus 7 because now you've changed the signs, you've multiplied it by minus. OB, however, remains the same, 3 4. So minus 4 plus 3 is minus 1, minus 7 plus 4 is minus 3 as well. Okay, so either way you do it, the answer remains the same. Okay, and there's no obligation that you have to do it a certain way. No, Omer. Okay, this is the only for your batch, this is the only clause. Okay, all right, now so I'd like you guys to quickly do part C and part E. Okay, following the same rule, there's nothing new, just so that you sort of get into the flow of things. Just do part C and part E and we'll move on to the next concept. 3 and 1, that's correct. Good job. And let me know when you have the answer to part E. I'll write it down over here.
Where is it? 1 and 7?
It's 1 and 7. Good job. So the answer to part C is 3I plus J. Okay. The answer to part D. Achha, I just realized that we were supposed to give the answer in the form of AI plus BJ. So it's going to be minus I minus 3J for the first part. Okay. And for part D, it's going to be I plus 7J. That's correct. Okay, great. So this was one important concept that we have done. If you guys have any questions, feel free to ask. And now we're doing the next concept, which is also fairly easy. It's unit vector. So far, all the concepts that we have done now, they're common in math as well. Okay. Unit vector is not in math. So this is something that's only in art maths. Okay. And it's very easy. Okay. So what's unit vector? By definition, unit vector is basically a vector divided by its magnitude. It's vector divided by its magnitude. Okay, if you look at the formula, so this is what the formula looks like. AB, so you put a little cap on it to show that it's a unit vector, is basically equal to the vector itself, okay, divided by the magnitude of this vector. Okay, so for example, let's say that you have AB, which is equal to 3I minus 4j. Okay, and you're asked to find the unit vector of AB. Okay, so here's what you're going to do. 3I minus 4j divided by the square root of 3 squared plus 4 squared. Okay, even though you'll do minus 4 whole squared, but eventually it will become 4 squared. So then what you have is 3I minus 4j. 3 squared is 9, 4 squared is 16. If you sum up the two, you get 25, square root of which is 5. Okay, now you can write it like this, or you can write it like this: 3 upon 5I minus 4 upon 5j, or you can write it as 1 upon 5 3I minus 4j. In fact, this is how you're supposed to write it. The second two, not the first one, but you're supposed to write it as the second two. My screen is frozen. Is that true? You guys can't see my screen? Okay, so why don't you just quickly disconnect and rejoin? Yeah, good idea.
Sir,
Yeah.
वो कौन से वेक्टर के सवाल होता है इसमें they give us like a ratio के AB is equals to K times of BC or something like
Yeah. So that could be with parallel vectors, that could be with collinear vectors. Okay, we will do full length example questions. Okay, so abhi to dekho, we will do some questions from the book. Okay, and then we'll have enough time to do past paper questions as well. And you will notice that the questions that contain these concepts, unit vector, addition, subtraction, they're all very similar to each other. That's the thing about admaths. You look at every single, if you look at plenty of questions of every single topic, you'll notice that they're all very similar to each other. So vectors mein, you will notice कि हमेशा एक ही तरह का सवाल आएगा. And I'm not talking about the velocity vectors, okay? You will have to form the same vector using two separate constants, okay? Sometimes lambda, sometimes mu, sometimes... Yeah, these are the two mostly used letters, lambda and mu, okay? And then you will have to find out the value of lambda or the value of mu, okay? Through solving them simultaneously. No, Taha, we won't have enough time to do velocity vector today because I want to do past paper questions of these type of vectors, because they're, even though it's the same topic, they fall under vectors, but the questions are such that they're kind of better off treated independently. Okay, questions be independent hote hain. Okay. All right. So let's just quickly do a few questions of unit vector. और ये जो highlighted हैं आप लोग ये कर लें, काफ़ी है. Here. Go ahead. Part A and Part C. Oh, Part D, sorry. Okay, so we have the answer to Part D. It's correct. It's 1 upon 17. Bracket 8I minus 15j. Okay, anyone who would like to give me the answer to Part A? It's pretty easy.
1 upon 10 bracket 6I plus 8j.
Yep. Okay, great. All right, now let's start doing some not full length questions, but like you can say half length questions where we will learn the use of unit vector and the use of position vector. Okay, so here's one question. Let's see what it says. So it says O is the origin and P is the point 1, 5 and PQ is 3, 5. Find OQ. Okay, so that's fairly simple. So if you have the point P, the first thing you should do ideally is write it in vector form. Okay, so if P has coordinates 1, 5, that means the vector is going to be OP 1, 5. Okay, and you're given PQ, okay, which is 3, 5. So how can I use these two to find OQ? Okay, so if you think about it, you have OP, you don't have OQ, but you have PQ. Okay, so write down, if I subtract these two vectors in a way that I do OQ minus OP, that will give me what? That will give me PQ. Okay, now I don't have OQ, fine, fair enough, but I have OP and PQ, so that's good enough for us to find out OQ. So if you want, you can make OQ the subject immediately and write it as PQ plus OP. Okay, or if you thought of it directly, like for example, if you thought of it immediately as what if I do OP plus PQ, and that should give me the answer, so that's even better. Okay, But normally it's best that you do it systematically, just to be on the safe side. Not that you're going to be graded or you're going to be marked on this or anything, okay? But it's better to do everything systematically, okay? So this equation is good enough for us to find out OQ, or the coordinates of Q. So OP हमारे पास है, it's 1 5. We have PQ, which is 3 5. Now all I have to do is I just need to add the 2. So 1 plus 3 is 4, 5 plus 5 is 10, and there you go. That's OQ. Okay, pretty easy. Now part B is the same, more or less. It says O is the origin and E is the point, minus 3 4. Okay, O is the origin and E is the point, minus 3 4. So first thing I want to do is I want to write OE. Okay, so what does OE look like? Minus 2 7. Okay, and you have EF, which is equal to, no, wait a minute, OE is not, yeah, thank you, OE is minus 3 4, EF is minus 2 7. Okay, now anyone who can tell me the equation which will help me find out OF, which is the position vector of F?
EF minus EO.
EF minus EO. Okay, all right, not bad. This will give us OF, okay, but this will require some changes. So EF will write as it is, minus 2 7. EO, however, will now be 3 and negative 4. Okay, so just be careful. Minus 2 minus 3 is minus 5. 7 minus minus 4 will become 7 plus 4, which will then become 11. Okay, so that's correct. Good job. Now, as always, take a good look at it. Let me know if you have any questions.
Shouldn't we just do OE plus EF?
We could have done that. We could have totally done that. Like I said, you could have. Doesn't matter how you do it. Okay, you will get the same answer. Umar, this Ramzan, inshallah. In the first 20 days of Ramzan, plan is to complete the syllabus. Okay. All right. So what I want you guys to do now is quickly do part C, and then we'll do some more questions. 1 3 is correct. Good job. Okay. So again, here also you have multiple options. You can do NM. No, wait. You can do, so you have OM and you want to find out ON. So, NM plus MO, but that will give you NO, and then you would have to change the sign. Okay, let's try something else. OM plus MN, but then again you would have to change the sign. So doesn't matter how you do it, answer same hi aayega. Okay, but just be careful. Whatever it is that you're doing, just be conscious of it. All right. Okay. Now here's another question, which I'm gonna solve for you guys. Okay, because it's fairly new, but it's not that difficult. Okay. So here it says relative to an origin O, the position vector of A is minus 7, minus 7. Okay. Now if you want, just to make your life easy, and if you don't want to deal with I and J over and over again, you can write it like this for a while. But then when you're giving the final answer, you can give it again in IJ form. Okay. It's just that when we write it like this, our calculations become a whole lot easier. Okay. Then it says, and the position vector of B is 9i plus 5j. So I would prefer to write it like this. OB equals to 9 and 5. Okay. The point C lies on AB such that AC equals to 3 times of CB. Find AB. Okay, so this requires a bit of work. Okay. The first part at least, not the second part. The second part at least, not the first part. So in the first part where you have to find AB, all you got to do is OB minus OA. Okay, and that's good enough. OB is 9 5 minus OA means minus 7 minus 7. Okay, so be careful. 9 minus minus 7 will become 9 plus 7, which is 16. Okay, 5 minus minus 7 will become 5 plus 7, which is 12. And there you go. That's part A. Pretty easy. Okay. All right. Then it says find the unit vector in the direction of AB. Acha, I just realized that this question thoda sa crop ho gaya. Just a minute. Let me share the actual question with you guys, because the first two parts are fairly easy, and that's what I was thinking. Okay, there's nothing difficult about this question. So here's the actual question. Okay. So the first part is still AB. Part B is that you have to find its unit vector. Pretty easy. Part C is that you have to find out the position vector of C. Okay. So let's do part B. For part B, we will do the vector AB divided by its magnitude. So that shouldn't be difficult. So that means 16i plus 12j divided by square root of 16 squared plus 12 squared. Okay, can anyone work out the square root of 16 squared plus 12 squared? In the meantime, I'm just writing it in IJ form. Yeah, 16i plus 12j. Okay, anyone who's worked it out? 20. Alright, sounds good. So here we have 1 upon 20, bracket open, 16i plus 12j is our final answer. Okay. Pretty easy so far. Now here's part C, which again is not difficult, but since it's new, you might find it slightly challenging, but will get easier when we do enough questions. So part C says find the position vector of C, which basically means that we have to find out OC. Okay. And notice that this is something that we haven't used so far anywhere in the question. Okay. So let's rewrite this. AC equals to 3 times of CB. Okay. Now here's a task for you guys. Can you break down AC for me using the position vectors of A and C?
OC minus OA.
That's correct. OC minus OA will give us AC. Okay, perfect. Just like that, can you break down CB for me? Perfect. OB minus OC. Okay. Now, bear in mind that what we have to find is OC. Okay. And this makes life easy. Why? Because we have OA and we have OB. So all we have to do now is we have to get all the OCs on one side, whatever we have to do, not cross multiply, but like expand, simplify, whatever it is that we have to do. And then let's see what we're left with. Okay. So let's do just that. OC minus OA, so I'll just rewrite the left hand side as it is, equals to 3 times of OB minus 3 times of OC. So if I get all the OCs on one side, it's going to be OC plus 3 times of OC, and if I get everything else on the other side, so that's going to be 3 times of OB plus OA. Okay. How does that help? Well, what's OC plus 3 times of OC? So that's going to be 4 times of OC. It's like x plus 3x. Okay. It's not any different from normal addition. Okay. Because we're not adding vectors over here. Okay. That part comes later. 4 times of OC equals to 3 times of OB plus OA. Sorry, not minus. So now all I have to do is find out what OB is. We already know what it is. It's 9, 5. Okay. So 3 times of 9 and 5. And in it, I need to add OA, which again is something we know already. That's minus 7 and minus 7. Okay, and then when I have the final answer, what do you think I need to do with the final answer? Once I work this part out, what do you think I need to do? Divided by 4. Good job. So 9 times 3 is 27. 3 times 5. Actually, by the way, don't think that this 3 will only be multiplied by 9. Okay, since this is vector multiplication, it's like multiplying matrices. So you'll multiply 3 by 9 as well as 5. So 27, 15 plus minus 7 and minus 7. So 27 plus minus 7 is going to be 20, and 15 minus 7, what is that? 8, is it? Yeah, it's 8. Okay, so bear in mind, it's not the end of the question. This is still OC. This is still 4 times of OC. So OC is going to be 20 upon 4 and 8 upon 4. Okay, now obviously we're not going to leave it like that. OC equals to 5 and okay. Now I could have skipped a few steps in between. Like for example, you could have just written this as OC directly. Okay. But the reason why I did it in such an elaborate manner is so that you guys understand. And once you understand it, once you know exactly how to do it, you can skip a few steps in between if you're feeling extremely confident. Okay. If you're not, then I would suggest you don't. So there you go. It's part C mainly that was tricky in this question. So if you have any questions, feel free to ask. I am going to give you guys another question to solve, similar to this. Okay, do we have the answer?
Yes.
To the first part at least?
Sir, it's 20 minus 21.
20 minus 21, let me check. OB minus OA, 10 minus minus 10 is 10 plus 10, which is 20. Yep, 20, 21, that's correct, good job.
And OC is 30 minus 30.
OC is, I'm sorry, can you repeat that?
30 minus 32.
30 minus 32. Okay. I'll just quickly solve for OC. Okay. So you'll break down AC, which is going to be OC minus OA. Okay, and thankfully you already have AB. If you didn't, you would have then used the rule of subtraction to find it out. Okay, but now that you do, just replace it with 20 and minus 21. Okay, so OC then becomes, so 2 times 20 is 40 and 2 times minus 21 is minus 42. Okay, and in it you now need to add OA, which means minus 10 plus 10. So this becomes 30 positive and negative 32. So there you go. Here is OC. All right. Now take a good look at what I've done. Let me know if you have any questions. Okay. So let's see what it says. It says find lambda and mu such that lambda times p plus q equals to 36i minus 13j. Now one thing that you should keep in mind is that you will have to at some point solve it simultaneously. Okay, so it's best to start with that in mind. Okay, so you know where you're heading towards. When you know that you will have to eventually solve simultaneously in order to get what you want, that means now from the get-go you're looking for two equations. Okay, so thoda vision हमारा clear हो जाता है. So lambda p plus q. Okay, now what you can do is, by the way, you can write it in point form. Okay, like column vector form, sorry. Instead of having this in IJ form, you can write it in column vector form if you want to make your life easy. Okay, so P can be written as 7 minus 2. Okay, and Q can be written as 1. Okay, why? Because the coefficient of I is 1 and the coefficient of J is mu. ठीक है, इसको हम lambda बोलते हैं. I'm sure science students would know what this is, but even if you're not a science student, it's okay, nothing to worry about. So this is something that we call lambda, and this is something that's called mu. Okay, these are what, Greek letters? Yeah, Greek letters. Okay, just you know how we have alpha, beta, gamma, delta. So it's one of those. All right, now lambda times p plus q equals to 36i plus 36j basically means 36. Oh, sorry, 36i minus 13j. So 36 minus 13. There you go. Okay. Now what I'm going to do is I'm just going to replace p with whatever the vector is and q with whatever the vector is. So lambda times p basically means times 7 and minus 2 plus q means 1 and mu. Okay, equals to what? Equals to 36 and 13. All right. Now this is the point where we start making two equations. Okay. Now, by the way, you guys are lucky because we won't have to solve these two equations simultaneously. We'll just find our answer. We'll find lambda and mu with the help of one equation each. Okay. So if I multiply lambda and 7, what happens? Here's what we get. We get 7 lambda, and this lambda will get multiplied by minus 2 as well. So minus 2 lambda. Okay. Plus 1 and mu. Okay, equals to what? Equals to 36, and I just realized it's minus 13, not positive 13. So 36 minus 13. Okay, now what we'll do is yeah, thank you for pointing that out. Now what we'll do is, so here's the x component of the first vector, here's the x component of the second vector, here's the x component of the vector after the equals to sign, and you know, together they form an equation. Okay, so this means that 7 lambda plus 1 equals to 36. All right, now if you want, you can solve this equation further, find the value of lambda, or you can write down the two equations first and then solve them one by one. Okay, in fact, I'll just write down the two equations side by side, and then we'll solve both of them to find out the value of lambda and mu. So here's the y component, or you can say the j component of the first vector. Here is the j component of the second vector. Here's the j component of the vector after the equals to sign. So what does that mean? That means minus 2 lambda plus mu equals to minus 13. Okay, so here's the second equation. If you look at the first equation, you can see that this equation is good enough for us to find the value of lambda. So 7 lambda equals to 35. Lambda equals to 35 upon 7, which is 5. And there you go. Lambda ki value aa gayi. Now in order to find out the value of mu, we will plug in the value of lambda in the first equation. So that means minus 2 into 5 plus mu equals to negative 13. So minus 10 plus mu equals to negative 13, which means mu equals to minus 13 plus 10, which is minus 3. And there you go. We have our value of lambda and the value of mu. And as always, take a good look at what I've done. Let me know if you have any questions. So if you don't, that's great. Now I want you guys to do question number 9. without my help. Okay, it's exactly the same pattern. Just do it systematically, okay? The more systematically you do it, the less chances there are of getting it wrong. Okay, I can see that you guys have your answer. So, batai, what's the value of lambda and what's the value of mu? Lambda is -2. That's correct. Omar, good job. And mu is 3. Okay. So I'll wait here for a minute. I hope everyone who has done it is getting the correct answer. In case you're not, see what you've done wrong. See if you can find it out yourself. If not, then let me know. I'll solve it. Now we are going to do some full length questions. Okay. So we have covered all the concepts. Okay. Other than, of course, velocity vectors. All right. So we're going to do some full length questions. Okay. From the book first. And then we'll transition towards past papers. Okay. So it says here OA equals to A and OB equals to B. So first thing you want to do is you want to read the question. Okay. So OA equals to A and OB equals to B. Acha, yeah. R is the midpoint of OA. Okay. So keep looking at the diagram as well. All right. And OP equals to 3 times of OB. All right. OP is 3 times of OB. Okay. So we'll figure this out later on. First, let's read the entire question. AQ equals to lambda times of AB and RQ equals to mu times of RP. Okay. Find OQ in terms of lambda, A and B. Okay. Now I'm going to read the question again and I'm going to start marking the vectors. Okay. So if OA equals to A and OB equals to B and the question tells you that R is the midpoint of OA. So how much do you think vector OR is going to be, considering that OA is A and R is the midpoint of OA? So how much? A upon 2 or half A? Take it. That's correct. A upon 2 or half A. Perfect. Okay. Now, as far as vector OB is concerned, that's B, not according to me, according to the question. Okay. And as far as vector OP is concerned, again, not according to me, but according to the question, how much is that? How much is vector OP? Considering that it says OP is 3 times of OB. So OP naturally becomes 3B. So this is 3B. And you know, while you're at it, here's what I would suggest. Find out BP. How much do you think BP is going to be? 2B. Perfect. Okay. So this you'll realize will make your life easy. Okay. Now let's see what we can do in order to go from O to Q. Okay. So let's see. We can go from OP to PQ. That will give us OQ. Okay. And bear in mind that you already know what AQ is. Okay. You know that AQ is basically lambda times of AB. Okay. Now let's see what else we can do. So if let's say if this is what I opt for, okay, this will require a bit of trial and error. All right. So be open to that. Let's say if this is what I opt for, that if I do OB plus BQ, then I don't know what BQ is. Okay. I know nothing about BQ. Okay. But if I do OP plus PQ, again, there's a problem. I don't know what PQ is. Okay. However, if I do OA plus AQ, okay, that means if I go from O to A and then from A to Q, that's a better option. Why is that a better option? Why is OA plus AQ a better option compared to all the other options that we looked at? We have the values. Okay, we don't actually have the values. We actually know what AQ is in terms of AB. Okay, in terms of lambda and AB. All right. So that's why this is the better option. And notice that the question is telling us to find out the vector in terms of lambda, A and B. Okay, the question is not expecting you to find out the value of lambda immediately. Okay, that we'll do in part C. Okay, so I hope everyone understands why this is the route that we have opted for and not any other route. Okay, if you don't, feel free to ask. All right. So OQ is now going to be equal to A plus AQ, which we now know is basically lambda times of AB. Okay. Why? Because it's mentioned in the question. The question told us that AQ is equals to lambda times of AB. Okay. Acha. Now, the thing is, this still doesn't cut it. Okay. We still have to do something about AB. So what is it that I can do about AB which will then change it from AB and bring it in terms of A and B. Okay?
Negative A plus B.
Yes. So technically, what are we doing over here? Technically, what we're doing is we're rewriting AB as OB minus OA. Okay? Or what you can do is you can basically think about it this way. Okay? You can look at the diagram and then form vector AB. So forming vector AB means going from A to O and then from O to B. Okay? So whatever suits you, doesn't matter. You can find out AB over here, okay, which is going to be minus A plus B, or you can do it like the way I've done it over here. So either way, irrespective of what you do, OQ is going to become what? A plus lambda into minus A plus B. Okay? Now, I would suggest that you don't leave it over here like that. Okay? Although it's good enough. Okay? Our answer is correct if we leave it over here, but that's not what I would suggest. So I would suggest the following. A minus lambda times of A plus B. Okay? Now, in the first two components, is there something I can take common? I can take A common. Okay? So if I take A common, I get 1 minus lambda plus B. Okay? And I will suggest, just a minute, I will कोई कुछ कह रहा है?
Lambda B.
Oh yeah, lambda B. Yeah. Thank you. Lambda B. Okay. So this is how I would suggest that you write it. Okay. Why, you'll find out later on. This just makes it clearer to see what the coefficient of A is or what the coefficient of B is. Okay. Now, this is the first part. Before I do the second part, let me know if you have any questions regarding the first part. Okay, great. All right, so here's part B. Now, in part B, notice that you have to find the same vector, but this time you have to do it in terms of mu A and B. Okay, so that means we have to use the vector which we know in terms of mu. Okay, now for this part, I want you guys to help me out. Suggest another route which will take me from O to Q. Okay, and that route should somehow have mu in it. So take your time, take a good look.
OR plus RQ.
Very good. OR plus RQ. Why is that? Why is OR plus RQ a good option? Because we know what RQ is in terms of mu R and vector RP. Okay. All right. Now that we still have, there's still, the job is still not done. Okay. You can say it's 20% done. So OR, as we know, is half A. Okay. And RQ, as we know, is mu times of RP. ओके अब RP के लिए हमें ज़रा थोड़ी मेहनत करनी पड़ेगी. कैसे करेंगे अभी देखते हैं. Half A plus mu. Now you can look at the diagram and see how we can form vector RP. Okay, or you can use OR and OP. Okay, it's up to you. But my suggestion is, if you have the diagram in front of you, it's best that you use the diagram. So can we form vector RP using the diagram, which basically means starting from R and going to P?
Negative half A plus 3B.
Yes. RP will be equal to minus half A plus 3B. Okay. So we can replace RP with minus half A plus 3B. Okay. And then, of course, if you leave it over here, it's fine. But eventually, you will have to bring it in this form. Okay. So OQ equals to half A minus 1 upon 2 mu times of A plus 3 mu times of B. It's always best to write A and B later. Okay. Like at the end. Whatever constant it is that you have to write that first. And then write everything else after that. Okay. So in the first two components, you can see that I can take A common. If I do that, so I have half minus half mu. So I factored out A and 3 mu B as it is. So here we have OQ. Okay. And once you do enough questions now, you will for sure know what the third part is going to ask you. Okay. अभी तो चलो हमारा पहला क्वेश्चन है, ठीक है, बट जब हम अच्छे खासे सवाल कर लेंगे ना तो फिर आप काफ़ी predictable हो जाएंगे ये सवाल. In part C, the question is now asking you to find the value of lambda and the value of mu. Now the good thing is the question has made us do all the hard work. Okay. Now if you give this to even like a 9th grade student who only knows simultaneous equations, he or she would also be able to do it. Okay, because all they have to do now is just compare, form two equations, and solve. Okay, so yes, the constants are such that we don't deal with very often. Okay, so you might find that a little uncomfortable, but again, conceptually there's not much going on over here. So here's OQ expressed in terms of lambda a and b, which is going to be equal to OQ expressed in terms of mu a and b. Now you guys tell me, what do you think we're going to do next?
So do we have to write A and B while solving?
No. We are going to solve it now, and when we're solving it, we don't have to write a and b. Okay. So yeah, someone was saying something? Compare. Okay. So here's the coefficient of a, and here is, or you can say the component of a. All right. And here's the component of a on the right hand side, and they both have to be equal. Okay, because they're both the same vectors. So 1 minus lambda equals to, so here's how I would prefer to write it, 1 minus mu upon 2. Okay, so that'll make the cross multiplication part easier. Okay, and let's write these equations nicely. So 2 minus 2 lambda equals to 1 minus mu. Let's write it in such a way that we have mu, lambda, and then a constant, or perhaps lambda, mu, and then a constant. Okay, you know how x, y, and then a constant? Is तरह से हम लिख रहे हैं इसको. So you'll have mu minus 2 lambda equals to 1 minus 2, which is minus 1. So let's call it our first equation, and let's leave this here for now. Now let's try and form another equation, which we can solve pretty easily. Okay, so lambda equals to 3 mu. इसको भी ज़रा तमीज़ से लिख लेते हैं, तो ये हो जाएगी 3 mu minus lambda. So I've taken lambda over to the other side. Okay, equals to 0. Here's your second equation. Now I'm writing it like this in such a way so that whatever method that I opt for, elimination, actually not substitution, but so the method that I opt for, which is elimination, not substitution, is easier. Okay, but we're gonna save some time and we're gonna do it in a calculator. Okay, so 1 minus 2 equals to minus 1, 3 minus 1 equals to 0. So here we have the value of mu, which is equal to 1 upon 5, and the value of lambda, which is equal to 3 upon 5. Okay, I should mention here that I've solved it simultaneously. Okay, so that later on when you guys are doing a revision, you know what we've done. Solve simultaneously to find mu and lambda. Okay, and there you go. That's it. The end of the question. As always, take a good look at it. थके तो नहीं आप लोग? Sir, can we do it in our calculator? And we, okay, so sadly we have to show the working. Okay, but you can and you should check your answer. Okay, that's non-negotiable. लेकिन working दिखानी पड़ेगी आपको. और फिर इसके बाद we will do past paper questions. Okay, I have taken out some past paper questions which we're going to solve, so we'll do that inshallah. Alright, so here it is. अच्छा एक काम करें. The first two parts I'd like you guys to try. Okay, you guys can do it, should not be that difficult. Okay, and when you're done, let me know. So OX is, if you think about it, basically equals to lambda times OY. So this question is slightly different in the sense that here we don't have to add or subtract two vectors. Okay, it's just OY. OY, however, will be found by adding two vectors. Okay, so if you want to find out OY will be equal to A plus 2B. Okay, so if you do that, so that's going to be lambda A plus 2 lambda B. Okay, all right, good job. Now just like that, can you guys do part B, and then we'll do part C together. Part B mein you need to find OX again, but this time you need to do it in terms of mu, A and B. I'll write it down.
B times 3 minus mu 3
Mm-hmm.
plus mu A.
Yeah, perfect. Okay, except that we write A first and then B. Okay, but your answer is correct because there's nothing wrong with that. Okay, so I'll write it down over here. So in order to find OX in terms of mu, A and B, here's what you need to do. You need to do OQ plus QX. That's going to give you OX. Okay. Now the reason why we've opted for this and not anything else is because we know what QX is in terms of mu. It's given in the question. So OX is equal to OQ, which is 3b plus mu times of qp. Now qp is something that we will have to find out, so we can do that very easily. From q to o is minus 3b, and from o to p is a. So ox equals 3b minus 3 mu into b, okay, plus mu a. So just write this nicely so that part C becomes easier. So this is going to be mu a plus 3b minus 3 mu into b, okay, and then take b common again to make life easy. So it's going to be mu a plus 3 minus 3 mu into b, okay. So you have ox in terms of lambda a and b, and you also have ox in terms of mu a and b. Now part C, very predictable. Now you have to find out the value of lambda and mu, okay. So you can form equations straight away. You can see that here you have lambda, and the component of a in the other ox in terms of mu is mu. So lambda equals to mu is your first equation, okay. So that means lambda equals to mu. So whatever the value of lambda turns out to be is going to be the same as mu, okay. Now we try and form the other equation, okay. And this also, in fact, if you want, you can just write this nicely so that it's easy for you to solve. Just write it as lambda minus mu equals to 0. So here's your first equation, okay. Then we form the other equation for which we pick the components of b. So the components of b are such that you have 2 lambda equals 3 minus 3 mu, okay. And then this, if you rearrange, so it's going to be 2 lambda plus 3 mu equals to 3. Now in this, since you know that lambda equals to mu, okay, so you can just replace mu with lambda and then solve it, okay. Makes no difference. But if you solve it simultaneously, okay, solve simultaneously, and if you do that and if you do it correct, this is what you end up with. Lambda equals to 3 upon 5, and mu is also equal to 3 upon 5. And there you go. That is your final answer. So as always, take a good look at what I've done. Let me know if you have any questions. Next, we're doing past paper questions. Okay, great. So here's a past paper question, okay. Again, make sure to first read the question carefully before you do anything else, okay. So here it says the diagram shows triangle OAC, okay. The point B is the midpoint of OC. The point lies on AC such that OY intersects at AB at the point X, where AX and XB are in the ratio 3:1. AX and XB are in the ratio 3:1. Okay, so this will come in handy later on. Then it says it is given that OA equals to A and OB equals to B. All right. Find OX in terms of lambda, A, and B. Oh, sorry, in terms of A and B. There's no lambda over here. Giving an answer in its simplest form. Okay. Now, this question has something very important which I want to explain to you guys, and that's this ratio over here. AX and XB are in the ratio 3:1. Okay, so that means AX is 3 parts and XB is 1 part. Okay, now if I ask you if AX and XB are in the ratio 3:1, so what is the total number of parts in which this line has been split into? Considering the 4, very good. AX and B. So here's 3 and here is 1. Okay, so this means that AX and XB are in the ratio 3:1. So what if I want to write AX as a fraction of the total? So AX, if I want to write it as a fraction of the total, you know what that's going to be? That's going to be 3/4 of AB. Okay, or 3/4 of AB. Think of it this way, that you have two people who are dividing, let's say, a profit in the ratio of 3:1. That means what they've done is they've taken the total profit, split it into 4 parts, and now A is taking 3 parts and B is taking the other 1 part. Okay, so that means A is taking 3/4 of the total and B is taking 1/4 of the total. So just like that, you have this line over here, which and this point X over here, such that AX and XB are in the ratio 3:1. That means altogether this line has been divided in 4 parts. A is taking 3 of the 4 parts of the total, which is AB, and AX and XB on the other hand is taking 1/4 of the total, which is AB. Okay, so figuring this out in the beginning is very important, will save you a lot of time. and will prevent you from getting confused later on. Okay, so now if I want to find out OX, let's see what I can do. So OX can be found by basically going from O to A and then going from A to X. Okay, O to A and then from A to X. So as far as OA is concerned, things are pretty straightforward. It's going to be A. But what am I going to do about AX? So I don't know what AX is, okay, but I do know that AX is basically 3/4 of AB. Okay, AX is what? AX is 3/4 of AB. So that's what I'm going to replace it with. I'm going to replace AX with 3/4 of AB. And how does that help? Now that I can find out what AB is, I can find out OX as well. Okay, how can I find out AB? For AB, all you have to do is go from A to O, which is going to be minus A, and then from O to B, which is going to be plus B. So OX becomes A plus 3 upon 4 into minus A plus B. And all you have to do now is just simplify it. So OX equals to A minus 3/4 of A plus 3/4 of B. Okay, now all you have to do is simplify A minus 3/4 of A. So all you can do is in your calculator just do 1 minus 3 upon 4. So that's going to be 1 upon 4 A. So 1 upon 4 A plus 3 upon 4 B. And there you go. That's your final answer. So before I move on to the next part, take a good look at this. Let me know if you have any questions. Okay, great. Now the next part is find AC in terms of A and B. Okay, so how will I find out AC? I'd like you guys to do this. It's a 1-mark question. It's fairly easy. I'll copy this, bring it over here. Okay, and there's something else to make a note of. That is B is the midpoint of OC. Okay, so this is something that we should have done something about it at the beginning. If B is the midpoint of OC, then what do you think BC is going to be equal to?
B.
It's going to be equal to B. Okay, so we'll write it over here. And yes, Umar, your answer is correct. Okay, so AC can be now found very easily. All you have to do is go from A to O, which is going to be minus A, and then from O to C, which is going to be 2B. So minus A plus 2B is your final answer as far as AC is concerned. Okay, so there you go. That's it. That's your answer. Okay, now here is part C. So we'll take help. We'll use this we'll use this diagram over here. So it says given that OY equals to H times of OX. Okay, OY equals to H times of OX. Find AY in terms of A, B, and H. Okay, so let's see what we can do in order to get from A to Y. So one way to go from A to Y would be that we go from A to O, okay, and then we go from O to Y, okay. And that's the best possible option. Why is that? Because we can also go from A to O and then from O to C and then from C to Y. So the problem is, yes, we have AO, yes, we have OC, but we don't have CY, okay. So that's why what we're going to do is we're going to go from A to O and then from O to Y. So let's write that down. AY equals to AO plus OY. Okay. Now, thankfully, we can see that AO is minus A. And as far as OY is concerned, we know that OY is going to be H times of OX. Okay. Now the question is, how do we find out OX? Have we found out OX? Yes, we have. We've already done that in the first part, so we don't have to worry about anything. All we have to do is just replace it with 1 upon 4a, okay, plus 3 upon 4b. Now, in this question, it hasn't really mentioned that we are supposed to simplify it, so even if you don't, that's fine. But I would suggest that you do it because, like as you can see in part D, that you have to find AY again in terms of some other vector, and then you have to find the value of H and M. So I would suggest that you simplify it. So AY will be equal to minus A plus 1 upon 4 HA plus 3 upon 4 HB. And then if you want, you can take A common. So that's going to be minus 1 plus 1 upon 4H times A plus 3 upon 4H times B. Okay, so there you go. That's AY simplified. Now again, you have to find out AY, okay, and AY this time, you know, is basically m times of AC. So here you don't have to do any hard work. You know why? Because we already know what AC is equal to. The question has already made us find out AC. It's minus A plus 2B. So immediately I'm just going to replace it with minus A plus 2B, and now you can see that AY equals to minus MA plus 2MB. Okay, and the same AY is also equal to here. Now this is a 4-mark question, so you got to make sure that you earn all these 4 marks. So what we have to do next is form 2 equations and solve them simultaneously. So one equation is quite clear. Minus m is equal to minus 1 plus 1/4 of h. Okay, I would suggest that you rearrange it. So if you take m over here and minus 1 over here, so it's going to be 1/4 of h plus m equals to 1. Here's your first equation. Okay. Now the next equation is 2m equals to 3/4 of h. 2m equals to 3/4 of h. So if you cross multiply, so it's going to be 8m equals to 3h. And then if you rearrange this, so it's going to be 3h minus 8m equals to 0. Here's your second equation. Now these are the 2 equations which you will solve simultaneously, and if you do that and if you do it correctly, let's see what you end up with. 1 divided by 4, the coefficient of h, 1 and 1, 3 minus 8 and 0. So here's what you end up with. H equals to 8 upon 5, which is the correct answer, and m equals to 3 upon 5, which is also the correct answer. So there you go. That's it. That's your answer. Now as always, take a good look at it. Let me know if you have any questions. Yep. Okay. So I'll write down the answer to the first 2 parts. Part A is a plus 2b or 2b plus a, doesn't matter how you write it, okay, but it's best that you write a first and then b. Okay, part B is 2a minus 2b. 2a minus 2b. Okay, देखो, so I'm sure what you're getting is correct, but there's a certain way that you need to write it, okay, that is getting all the a's on one side and getting all the b's on one side. Okay, so how do you go from O to X? We can do OP plus PQ. So here's what I'm doing. O से X जा रहा है ना, OP, PQ and then QX plus QX. Okay, this is the best possible route that we can take. So what's OP? OP is going to be 2B. Okay, what's PQ? PQ is A. Okay, and what's QX? QX is basically mu times of QS, okay, which we've already worked out, 2A minus 2B. Now you can leave it over here like I said, but you know, देखो यहाँ पे like I said, ये काफ़ी predictable सवाल हैं, आगे आपको लैम्डा और म्यू की वैल्यू निकालनी है, तो इसके लिए बेहतर है कि आप पहले से इसको A और B की फॉर्म में आप लिख लें. So it doesn't require a lot of work. OX can be written as, पहले तो हम एक काम करते हैं, पहले इसको expand कर लेते हैं, ठीक है. So OX will be 2B plus A plus 2 mu A minus 2 mu B. Okay, now if you get all the A's on one side and factor it out, so I'm doing 2 steps at once, so you'll have 1 plus 2 mu A common, and then if you get all the B's on one side and factor it out, so you'll have 2B minus 2 mu. Okay, and then right outside you will have, no wait a minute, 2 minus 2 mu, and then right outside you will have B. Okay, so 2b minus 2 mu b, imagine that we've written it together and then we factor out b, so you have 2 minus 2 mu. Okay, this will save you a lot of time. If you don't do it now in part E, so you'll have to do it anyway. Okay, now part D. Anyone who has done part D as well and would like to share their answer? You have to find OX again, but this time in terms of A, B and lambda. So OX,
Sir, 3 lambda A plus B.
Yeah, that's it. 3 lambda A plus lambda B. Okay, so OX is equal to mu times of OR, which is basically 3A plus B. Okay, एक काम करते हैं, इसको कॉपी करके यहाँ पे रख लेते हैं. So there you go. You can see that OX is equal to lambda times OR. So all you have to do is just find OR, which is going to be 3A plus B, and then multiply it by lambda. That's it. And then write it nicely to save some time. So OX is equals to 3 lambda A plus lambda b. Okay, and now, as predicted, the next part is that you now have to find out the value of lambda and mu. Okay, so this I would like you guys to solve. I'll make it easy for you. I'll write down the two OX's here. Okay, now form two equations and find out the value of lambda and the value of mu.
Sir, is mu 5/8 and lambda 3/4?
Yep, that's what it is. Good job. So the two equations are 3 lambda equals to 1 plus 2 mu. Okay, that's one equation. The other equation is lambda equals to 2 minus 2 mu. ठीक है, अब आपने जैसे करना है वैसे तो we can very easily add the two equations and eliminate. Okay, so in fact let's just do that. 4 lambda equals to 3, this gets eliminated. Okay, so lambda equals to 3 upon 4 and mu, as you said, is 5 upon 8. Yeah, good job, Omar. Okay, so let me give you guys another question. So wait a minute, there's part F and G as well. Part F says find the value of qx and xs. Okay, अच्छा इसके लिए एक काम करते हैं, सारी मेहनत हम कर चुके हैं, जब ये 1-1 मार्क क्वेश्चन हैं तो आपको चाहिए qx और आपको चाहिए xs. चलो ये मैं कर देता हूँ since it's new. Okay, I'll do it. Now notice that if you go back to the question, you have pretty much all that you need. Okay, the question told you that qx is basically mu times of qs. Okay, qx is basically mu times of qs. अब आपने क्या करना है, बस अब आपने जो इन्फॉर्मेशन जो आपने वैल्यूज़ निकाले हैं ना उन्हीं को यूज़ करना है. So qx is basically mu times of qs, right? We have the value of mu, so qx now is equal to 5 upon 8 times qs. Now you just have to write it the way the question wants you to write it. Okay, how does the question want you to write it? Achha, wait a minute. If you write it the way the question wants you to write it, you don't end up with the exact answer. Okay, there's something else that you need to do. So this is 5 upon 8. Okay, qx ratio qs is 5 upon 8. Now what does that mean? That means if qx is 5 parts, qs is 8 parts. All right, simple ratio. So now, keeping this in mind, can you tell me how many parts of these 8 parts is xs going to be? 3. That's it. All you have to do is 8 minus 5. Okay, and now can we find out qx ratio xs? Achha, we don't need to write down the vector sign because we're only finding out the ratio, right? So we can ignore that. So now the ratio of qx and xs is going to be what? It's going to be 5/3 or 5 over 3. And there you go. That's it. That's your answer.
So can you explain again, please?
Yes, I can. Okay, so what I'll do is, let me just erase this and do it again. Okay, now, so notice that the question is now asking you to find out qx over xs. Okay, and you have to find out the ratio. Keep that in mind. Qx over xs basically means that you have to simply find out the ratio. Okay, that's it, nothing else. So qx, this was given to us in the question, that qx is equals to mu times of qs. Okay, so what that means is that qx is equal to 5 upon 8 times of qs. Okay, now if I make a ratio of these two, so qx and qs are going to be in the ratio 5:8. What does that mean? That means if qx is 5 parts, qs is how many parts? 8 parts. Now through this information, can you tell me how many parts is xs?
3.
3. There you go. What did you do? 8 minus 5. Okay, so now do we have enough information? Yes, we do. Qx over xs are in the ratio 5:3. And there you go. That's it. That's your answer. Okay,
Yes.
चलो मैं पार्ट डी और पार्ट एफ और कर देता हूँ इसका, ठीक है, बिकॉज पार्ट एफ भी ज़रा थोड़ा सा it's new for us. Okay, now this is the information that was given to us in the question, okay, previously, where it said ox is lambda times of or. Okay, and now that we have the value of lambda, we know very well that lambda equals to 3 upon 4. Okay, अब सबसे पहले तो हम एक काम करते हैं, let's find out what is OX over OR. So OX over OR is going to be what? Is going to be lambda over 1 or just lambda. Okay? But the thing is, that's not what the question wants. What the question wants is OR upon OX. So how do I do that? If I turn this from OX upon OR to OR upon OX, so what is that going to be equal to? That's going to be equal to 1 upon lambda. Okay? Now, do we have the value of lambda? Yes, we do. We know that lambda equals to 3 upon 4. Now, what's 1 over 3 upon 4? 4 upon 3. And there you go. That's your answer. OR upon OX is 4 upon 3. And that's it. That's your answer. As always, take a good look at what I've done. Let me know if you have any questions.